Hi, welcome to this edition of my GXWorks 2 tutorials. Um, so again, on this one, I'd like to just go over some of the basics of how Mitsubishi does things. There's lots of ladder logic programming tutorials on YouTube and elsewhere on the web. I'm just going to kind of skim the surface of how Mitsubishi actually does the different types of instructions and kind of their own unique way of doing things. So I'm here in GXWorks 2. I'm going to create a new file. I'm using FX CPU at this point, ladder logic and simple projects for this project. I've not saved the previous project. Alright, shift insert will give us new rungs. First off, I'm going to cover the basics of few different small instructions. This rung we're going to throw a counter on, so I'm going to use M1 normally open contact as our initiator. M addresses are internal bits. Anything internal not going into or out of the PLC. These are just internal reference. So next instruction, again, just start typing or click here will bring up the enter symbol box. If that's not working for you, if you're getting maybe something like this instead, you need to make sure that you're in write mode, which is here. F2 would do the same, or in edit, let's see, right here, ladder edit mode, either read or write. You want to be in write mode. I'm going to throw a counter in. C addresses will give you the counter access, and in this case you don't have to place any of these symbols in, although this little brackety type thing would do the same thing. Actually, no, I'm wrong. The parenthesis will give you what you want there. So we have to enter the address, and then the C1 is our address, and then followed by a preset. So in this case, I'm going to toss in K5. K stands for, well, I'm not sure what it stands for, but I think of them as constant numbers. So if you don't want to put in an address reference, K will do a standard number in there. So the same diff could be done if you wanted to put in a variable here. D1. D is number or integer style addresses. They technically can be floating point and or real type addresses as well, but D1 would give us whatever number is held in address D1 would be the set point for that timer. Now I guess technically it's a duplicate, so we should have C2 be our timer, but so place a number in D1 would give us our preset there. Alright, so C1 being our timer, to reference when K5 would be reached, or when preset of 5 would be reached, we want to either, we can go up here to normally open and place in there C1 as our normally open contact reference of this preset reached, or in Allen Bradley it would be like a done bit value. There, to my knowledge, is not a good way to reference enabled bits and that kind of thing on that counter. This is very basic, low, or I guess technically high level programming, so there's not a whole lot of features. Some of that stuff you're going to have to build yourself. We could alternately use things like normally closed contact or a rising edge There's also falling edge context there as well. But in this case, we're going to just toss in a normally open contact. For this example, I'm going to put in a reset. And there I just started typing, and it recognizes reset as an output type instruction. So it's going to place it over there. So reset is the command, and we want to reference C1. So in this case, when M1 is pulsed, C1 will be incremented. When C1 reaches 5, it'll close this contact, which will reset C1, which is this. That'll place a 0 in. I'm going to put in another, well, yeah, let's go round 2 here. So M2, C2, if we start typing out, C2, nope, C2, K5. So I'm going to put in another counter of preset of 5. And I'm going to do a little something different here. The set reset. So reset can be used on either a integer or a bit style of instruction or data type. In this case, I'm going to go M3 and set M2. So here, again, I don't want to go too detailed here with how ladder logic works, but this is how a set instruction would look. And then I'm going to go, let's see, let's do a comparison. So comparison instruction gets placed in the bracket style of symbol. Now, it's very possible that you could just start typing here. Can't quite remember. So if we go C2 greater than, you don't have to type. So we're initiating this compare by giving it the greater than symbol. Then we enter our 2 variables. So C2 will be referenced, and I'm going to put in K2 as the other one. Oops. What did I do wrong? Okay, let me figure that out. Yeah, okay, my bad. You do have to enter the bracket there. So I'm going to say C2 is greater than, when C2 so as long as C2 is greater than K2, we'll continue with the run. So I'm going to say, let's see, reset, RST. So reset, like I said, can be used on bits. Set can be used on bits. So I'm going to say when C2 is greater than, when if C2 is greater than 2, we're going to set C1. Actually, let's set M1. So we have a real string of events happening here. Alright, now I'm going to just copy this rung here, and it's very important that you build the project before you do anything else, and I'll give you an example of what happens if you don't. Shift insert there to create a new rung. I'm going to plop that in there. In some cases, if let's see, if I want to fire up the simulator, and here's where, if you're not paying attention, and you're just clicking through to get stuff done, you're going to lose a lot of work. I've done this, and it's very aggravating. In this case here, which happens if you do not build your project before you upload, it's going to fire this message here, which says, if you don't read it, you lose work. But if you do read it, it says there's unconverted ladder logic in your program, and if you choose to continue, it's just going to overwrite that. So if you say yes, there, we just lost that entire run. So I've done this with a very large amount of work done, and it makes you very angry. But anyway, so I hope you can see this. I have a simulator running here. This little box, the simulator started with this little control window box here. Fires up a simulated PLC. You can see that it's powered and it's running in run mode. And it's actually in monitor mode currently. That's if you ever want to enter that mode, that's this box here. So you have write to PLC, read from PLC, start monitoring, stop monitoring, and so that's where we want to be currently. Let's set this up by going to, let's see, right here. So M3, in monitor mode, if you go Shift Enter, it will force the bit. That actually works with real PLCs as well. It's very handy for testing and forcing things. And Shift Enter to disable that as well. So we just set M2 by turning that on. M2 is on, which hit our counter. Now, usually I'd recommend using rising and falling edge contacts here. More details on that can be found with some other tutorials, but basically when you use a rising edge triggered contact, like this normally open rising edge here, it doesn't matter how long that contact is on, it's just going to hit that contact on the first pass through a program. In most PLCs, this counter would be just going up, 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 up. It'd be constantly counting for each scan that the PLC does, because, yeah, so this contact's on, so it's counting. In this case, it's not doing that, but I'd still advise that on all counters you use rising edge contact. It's just a safer way to play. So, so you can see we set M2. I'm just going to toggle that off and hit it again with M3. M3 is off, so we're setting this contact here. Now, if I'll take notice, our comparison is showing here, and we're currently equal, so next time I do hit that, which will be now, 3, that comparison comes on, M1 is set, and we are hitting our second counter up here. Let's turn that all off. And to demonstrate our reset here yet, let's see, we can just hit this one a couple more times, and there it went. So we're at 4, and it might blip just a little bit, but it's going to be fast, so don't be surprised if you don't see it. C1 hits its preset counter 5, and when it does so, C1 here, which is this address, comes on, and that hits the reset and turns that back to 0. Let's see, another go off and go back into write mode. Let's see, we could alternately use move instruction, MOV, and here we can set a value of K2, so a constant of 2. So we're taking this and moving it into, we're going to say C1. Basically what this is going to do is it's going to move this value into C1. So instead of saying reset, if we want to move it back to 2 instead, we can do that pretty easily here. You may have noticed this kind of kicked down into the next rung. It's because I didn't have the correct spacing in this box, or in the right view here. That's okay. When we build it, it's going to kind of shift back into a nice view again. So bring that up for us. Let's see. I'm just going to. Simulation seems to act a little funny when we do online write, which the FX5 series does support, and that can be done by using the Shift F5 keys. I'm sorry, Shift F4. That can save you a lot of time. Alright, so I just did a new upload, and I'm going to hit start monitor mode again here, and I'm just going to toggle through the count C1. So we're at 4. I'm going to toggle it again, and it should, since we're hitting our preset, it should bump the 2 into C1 as its new value. There it is. Alternately, for both the constants and for things like the move value and stuff, that can all be D series integer variables. And I'd highly recommend that you plan this out to some degree before you start programming, because it can get a little messy. So whether it be coming from your HMI or from other places in your program, all of these constants can be, don't have to be, but can be D numbers. Another thing I would recommend is when you do use these D numbers, you start with whatever number you want, but only use about every 5. Can be really helpful when you start getting into places where you need double word integers or 32-bit integers and higher. Also when you're using floating point numbers, I believe some floating point numbers, especially if you have a really large number and a float combined, it's going to need 64 bits. So you could potentially be using up to 4 of these addresses in one single number. That's all kind of one of the tricks to Mitsubishi programming. So you kind of have to keep track of that stuff on your own. It's not going to group your addresses together, or when you reference D0 and it's using up 4 variables. If you say D3 plus 1, it's still going to do that math somewhere else, and you could potentially be using, these 64 bits or whatever it is, and still be accessing D3 somewhere else or D4 somewhere else, and it's going to screw your numbers up, and you're going to be very confused. So in that case, I would suggest using, if you're referencing D0 in a double word or a 32-bit variable, I'd say just copy that description. And again, I'm over here in the global device comments. When we reference that, quickly stop here. Let's see, go back into write mode, and I'll say 0. Another way to access the comments is right here. Let's see if you, go enter. That's going to bring this up here, and Let's see, and then let's build before we forget and enable. Let's see, right here somewhere. We enable the comments. There we go. That's going to label. Now I have it kind of this monitor isn't set up well to display this nicely, but you can see there that it attaches those numbers or those names. Sorry. You can also do some stuff like let's see if we go edit and nope. It's up here. We click this little guy and we start typing. Nope. I'm sorry, a little confused here. Here we go. So if we want to label this whole thing, we can put that up there. There's run comments here somewhere too. There it is. Line statement. That'll put it over here so that you can kind of this way you can label kind of what's going out here or what this function is doing, and here you can label, you know, kind of break down your code into what the runs are doing, or sections maybe. So yep, that's how that looks. What else? Math. Yes, math is next. So I'm just going to create a new project just to easily clean that all up. Math is a little tricky in that you do one function, so a plus b equals c. That's 3 variables right there. And then to do another a minus c maybe, or c minus d, that's yet another variable. So it just stretches out a little bit. Now I think that something I haven't messed with doing here in Mitsubishi at all is I believe that you are capable of placing structured text into at least maybe that's GXWorks 3. I'd have to look into that. But structured text could simplify some of that stuff a little bit. There it is. Not quite sure how you access that here in GXWorks 2, but that may simplify things if you can do that. So I'm just going to go M1, and we're going to go add. Now, I mentioned double words or 32-bit integers. To do that, it requires a different function. So dadd is a double word addition function. And anytime that you place a variable, like so we did D0 and D4 here. Alright, I need to put one more in, but I'm not going to do that at this point. We're just going to stick with basic stuff here. That is going to automatically be, no matter how big these numbers are, it's going to involve both D0, D1, as well as D4 and D5. So because it's referencing 32 bits starting at this address, it's going to be referencing all 4 of those addresses. And that's where I caution you on making sure everything's documented well so that you know how much of that stuff is being used. And I'd say frequently go back to your global comments to make sure that stuff isn't being used before you throw it in there. Oops, I want D0, not DO. So yeah, and I think I mentioned previously in my previous video, Control F would be really helpful. Actually, I have that up here already for finding what stuff is in your program. And sometimes, especially if I'm editing a program that I did a long time ago, I'll just do a quick search for a variable before I use it, or before I stick it in my code, just in case for some reason I had forgotten to label it in my comments before. But stuff like a D word is only going to show you the first of those double word references. So, like I said, if I'm doing a D word integer and I'm starting at D0, if I search for D1, it's not going to show up in my program at all, but it's most certainly being referenced if it's being used in a D-add or similar instruction. So there's a whole string of different functions built for double word integers. Um, Most of them start with D. Like if I wanted to do a move into a 32-bit integer, that would be using a D move. Different functions like subtract are pretty easily found or used like that. Um, Frequently, you will find with uh, it, the collision of real or floating point integers, E will be used. Uh, if you're using a double word floating point, you will be using 4 of those addresses. One of those examples is D sub. That's a that description might actually be kind of nice. So actually, sometimes it's not at all helpful. This is one thing that I like to use a lot. This help button can actually be really helpful. Um, so there's that description there. If you click details, it'll break it down a little differently maybe. If you're familiar with the Mitsubishi number breakdowns, um, that'll show you there which ones are allowed and which ones are not. And if you have, which I don't currently on this computer, have uh, the help manual set up, which I'd very much recommend doing, especially if you're not familiar with programming. That will take you directly to the, the spot in the manual that references this particular form or instruction. So back to how this all started. Let's just do a basic, what we would sometimes call a heartbeat or a heartbeat counter. So M1, and we're going to do add D0 K1. So we're going to add, actually let's do 5 just because we can. D0, and the way this works is we're initiating the instruction with the add, which is addition. D0 being our first address. K5 is going to stand in for our second address, but it's a constant. We could put an address in there. I'm just going to do a constant for this one, and then we're going to finish it up by putting in our result, which is going to go into right back into D0 for this case. It's going to throw it over there. Let's build and download. Whoops. I need to restart my simulator. It's going to write to the PLC right away for me. Alright, and it's going to throw us right into run mode, or into monitor mode. So I'm going to go shift enter, and we can see that we're counting. The way this works is D0 plus K5, which would be 5, equals D0. And the next scan right away, it's going to say whatever's held in D0, which is 5 from the last scan, plus 5 is 10, equals D0 again. So each scan it's incrementing by 5. So that's an addition. Last time I tried this, it didn't work well, but we'll try it anyway. Go back into write mode, subtract, and Just for kicks. Nope, doesn't want to do. Download this. Now when you download, I think I covered this in my last video, but you can selectively throw into the PLC whatever you want. In this case, I'm just going to do everything. Oh. And then we'll close, go into monitor mode. Now I think it's not going to like this because, no, it is going to like it. Cool. So we're doing the same thing here, except we're subtracting 5 from D0 each time, which means we're going negative, of course. Yeah, so that's that. The next thing that we're going to go over, I think, will be the last, and that is a pretty simple little help, which can be used. Here, if you right-click on your instruction, if you go to Debug, Modify Value, this allows you to access the variable that you just clicked on, and actually you can put in whatever variable you want there. But if you'll notice here, we're negative 695. If I wanted to put in 500, hit set, and there we changed D0 to 500. That can be really helpful when you're simulating or testing or doing startup on a machine. Gives you some control over instead of having to reset your whole process. That can be really helpful. So I think that's all for now. I just hit half an hour of time, which is way more than I was expecting. But hopefully this was helpful in some way. And again, I'm not professing to be a pro at any means here at Mitsubishi, but I did put a lot of time and effort into learning how to do some basic stuff. And if I can save someone else out there at least half of my struggle to find out how to do stuff in Mitsubishi, it is a steep learning curve, and pretty much every manual has 5 different versions of itself that need to be referenced to pull all the information together. So if I can pull down your learning curve a little bit, I hope that I can do that for someone. Let me know if you like this, and the potential is that I'll end up doing some more. Possibly the next couple of videos will be in GXWorks 3 or in GT Designer. So yeah, look forward to hearing some feedback. Thank you.